Today we will learn about planning our bridge for success, the competition, the rules, etc. Let's watch this video by Mohawk College to get all of these ideas.
Hi there, and welcome to Building and Construction Sciences at Mohawk College and the annual Popsicle Stick Bridge Competition. In this video, I'd like to talk to you about who can enter and how to enter this bridge competition. There's fame and fortune to be won here, so let's get started. Let's talk about the rules. I'm going to go over them quickly here, but inside each one of the bridge kits, you'll find the document containing the rules, and it's absolutely critical that you familiarize yourself with those rules. Firstly, you can only use our materials. Those are the sticks and the glue that come out of the kit. This is one of the most important rules and the one that is usually violated the most. And this means that you can't even use last year's sticks or any sticks from previous competitions. You can only use the sticks that came in the kit that you bought this year. Secondly are the dimensional rules, and once again you'll find them at the bottom of the rule sheet in more detail. But basically they're simple yet critical that you follow. The dimensions are based on basically one popsicle stick. That dimension is 110 millimeters. That dimension is 10 millimeters. Hence, the bridge cannot be any higher than 20 millimeters above the testing jig support. So 2 popsicle sticks in height. Below the testing jig support level, we cannot be any lower than 110 millimeters. So again, 1 popsicle stick in height below the testing jig surface. Thirdly, the bridge cannot be any wider than 1 popsicle stick or 110 millimeters. Once again, these dimensions are maximum. You can use less than those dimensions if you want to, but you may not exceed those dimensions. And if you are building this style of truss that we refer to as an arch or a W shape, it becomes absolutely critical. This dimension between the faces of the test jig is 500 millimeters. And so your bridge, if you choose to build this style, must be able to fit in between the faces of the test jig. If it doesn't, we'll give it back to you and ask you to make it fit. Thirdly, the bridge cannot weigh any more than 250 grams. Now, I want to point out that inside of the kit that you have here, you have way more than 250 grams of sticks, because we know you're going to cut some, you're going to waste some, and so you're going to need more sticks than the limit. Bottom line is, if you were to use all of the sticks in the bag, you would be way over the weight limit. And once again, we would give you the bridge back and ask you to make it weigh 250 grams. So remember, we talk about using only our materials. That's absolutely critical. No toothpicks, no dowels, no other material is allowed in the competition here. So we're going to talk a little bit later about how to make round shapes out of popsicle sticks, but it's absolutely critical that they're made from our materials. So 250 grams, that's your top limit for weight. And finally, you must be the primary builder of the bridge. Can you get help with it? Absolutely. Can you get help designing it? Absolutely. If you know relatives or friends who are professionals, engineers and architects, absolutely use them for help. But once again, you must be the primary builder. So there it is, 4 simple rules to the competition. So let's talk briefly about what you're going to build. Basically, there are 2 styles of bridge that can be built. The first one we refer to as the true truss, which is probably what you most commonly see every day. The second style we refer to as the W shape, which in essence is a simulated arch. Now, the big difference between the two, in the W-shaped bridge, if this is a mock-up of the testing jig that we're looking at here, you can see that when the bridge fits into the testing jig, it quite clearly uses that jig for vertical support here, but also for lateral support in terms of being able to resist the thrust that we see in a typical arch. Okay? When we come over here and look at the true truss shape, the true truss only uses the testing jig for vertical support. There's nothing pushing against the sides of the support in any form of a true truss bridge. So to qualify as a true truss, there can be absolutely no dependence on the testing jig for lateral support of any forces that the bridge has to carry. When it comes to building structures today, what is one of the most predominant shapes that we see, whether it's a bridge or a hydro tower or a building of any kind? The answer is, let's take a look and see. If I start with this true truss. Basically, in my simple model here, if I start with a square shape, it can carry load, but the problem with it is that it can go unstable on us. So, how do I fix that instability? Because remember, going unstable is counted as failure. How do I stop this instability from happening? Answer, simplest solution is to create another piece and put another piece diagonally from corner to corner. And when I do that, all of a sudden we see now that not only can we carry load, but we have also stabilized the structure. It doesn't want to fall over under load anymore. So, how have I changed the shape and going from here to here? I think you see that I've created two triangles out of the square. And is there something magic about the triangle shape? I think there is, because not only can it carry load, but it's also a very stable shape. And if I put several triangles together, what do I end up with? A bridge, a hydro tower, the Burlington Skyway. Go and take a look. It's the triangle shape that you will see will be your friend in this competition.
Okay, so at this point we want to start planning what type of bridge we want to make, taking into account all the design specifications of the contest. And then we'll start building it.